So if we turn now to, the next one is shapes and sizes. It's session 2, or shapes and sizes. So let me just delete all these. So you should have it there in your notes. And you should be free from taking down particularly any of the material, really. Okay. Shapes and sizes. There will be questions on shapes and sizes in June on your paper. So paper 1, this question uses a number of formulae. You're given quite a lot of formulae in your tables. But remember that the formulae that they give you are only one version of the formulae. There's always different ways of writing the same equation, and they won't give it to you in the order in which is most convenient most times. So let's go back to something really, really fundamental. Let's look at the multiplication of two numbers for the moment, just the association of three numbers here. 2 times 3, the two numbers, to give us the third one, 6. So this multiplication of 2 times 3 is 6. You've done forever. But actually, within this one equation here, there are 2 more. 6 is also related to 2 by dividing by 3. So this multiplication process forward, you could take as a divide process back. So 6 divided by 3 is 2. Or equally, if you rearranged it, 6 divided by 2 is 3. So really in a form like this, you could see them like a triangle. Sometimes they use these on the physics courses and others. They put the 6 on the top. And the 6 is the product of 3 by 2. But if you were to leave out any one of these numbers here, you would find that the 6 was fully defined because it's 3 times 2. If you left out this number, well, this is on the bottom, so it's 6 divided by 2 is 3. Or equally here, 6 divided by 3 is 2. And there's a sort of a similarity and a consistency and an association that stays there. So using the triangle, any two numbers and their locations will give you the third one. So for example, here we got x is 2 by 3, x is 6. And if we need the missing number, we can say x is 6 divided by 2, or x is 3, or x is 6 divided by 3, x is 2. Now let's move from numbers for the moment and say, how would this come in terms of algebra, in terms of shapes and sizes, in terms of formulae? So how would this come in terms of algebra? We do a lot of rearranging of formulae on your course. It's like this riding the bicycle. You've done it a million times. It's so obvious, it's so fluid and so flexible, you know how to do it. So let's consider this equation for the area of a rectangle. Very straightforward equation. You've got W here, represented here by, well, W is the width, L is the length, and this A is the area. This will be generally measured in meters. This will be meters. And the clear giveaway in the exam will be that this will be in meters squared, or feet, and feet squared. The units will be different. So W, L, and A are associated in some way. And we're used to seeing that as A, area is length by width, or A is L by W. But just using the association before, it also says that area is length by width, but that area divided by length is width. Area divided by width is length. So within this one equation here, you have A is L by W, well, let's say A is L by W, but I was more interested in W rather than A. Well, then I'd want W to be on the right side of the equation. So I could just swap them around and say A is L by W, which must be equal to A. I just put the A on the other side again. So I end up with this bit. But if I'm just interested in the W, well, I'm multiplying by L here. So if I divided that by L, they'd cancel. and I get W is A over L. So in a way, no matter what form they give me the equation in, it looks like I can toss it around into 3 equations. So let's see if that's the way it works. A is L by W. L is A divided by width. In other words, if I just wanted L, well, the way I do things is really very, very, measured. It's step by step. A is L by W. Somebody says to you, please find the value for L. And you say, I want L to be on the left-hand side. If I wrote the equation with this on the left-hand side, I'd get L by W is A, just swapping it around. If 4 is 4, or if X is 4, 4 is X. That's okay. But I'm still interested in L, not L by W. So I don't want this W on this side at all. So how do I get rid of a W? Well, if it's multiplication, I divide. If I divide this side, I must divide the other side. Why do I divide? To get rid of it. And I end up with L is A over W. And similarly, no matter what way they ask it, if they say A is L by W, and they say find not L, because we found that, but find W. All you do is you say, put W on the left-hand side. To do that, you say, well, swap it around. L by W is A. Now I'm very happy with W, but not too gone on the L here. How do I get rid of a multiplication? Divide. They cancel. W is A over L. So just as we know that the numbers 6, 2, and 3 are related, 2 times 3 is 6, 6 divided by 3 is 2, and 6 divided by 2 is 3. Exactly the same applies to the area of a rectangle. And why do I do that? Well, I do that because invariably in the exam, they're going to give you the formulae to use, but they're not in the right order in which you want to use them. They will not say the area of, well, we will see them shortly. So the best way to solve most of these questions is through rearrangement. So let's imagine this equation you have in your book. You know it's there. You don't have to remember it. And they say that the volume of a sphere is given by the following equation. V is equal to 4 over 3 pi r cubed. Now, it'll be very rare if they say in a question, the radius of a sphere is 10 centimeters. Find its volume. Because all they're saying is, you type in 10, cube it, multiply by pi, multiply by 4 over 3, and you get your volume. You read the formula page, and it's done. Now, there might be one question in 10 like that. It's far more likely that they'll say, we know the volume of a sphere to be 100 cubic meters. Find R. And really what we're going to do now is like Sudoku. We're going to go in a step-by-step process to eliminate all of this stuff, so we just have R on the left-hand side. So we're going to say that if V is equal to 4 over 3 pi R cubed, really our focus of attention is R. That's what we're interested in. Now, the first thing I'm not really gone on is that it's on the wrong side of the equation. And the way I do that is I just flip it. So I say 4 over 3, therefore, 4 over 3 pi r cubed is equal to V. Not much better, but it's a start. At least it's on the right-hand side. Then I say, okay, what do I not like? I'm really not gone on the 3 here. So if I were to multiply that by 3, I'd have to multiply that by 3. If one banana costs 80 cents, 2 bananas cost 160. If a banana and an apple cost €2, 2 bananas and 2 apples will cost you 4. So whatever you do on the left-hand side of an equation, you've got to do it on the right-hand side. So let's just multiply. The reason I chose 3 is because it cancelled. So I get 4 pi r cubed is 3v. Now, 4 is just a multiplier. 4 is a number and pi is a number. Pi, like, say roughly 3. 4 times 3 is 12. 4 pi is just a number. It's just a multiplier. So really what this is the number of times r cubed. And I don't like multiplication. I just want to simplify this right-hand side. So let's go at that. The only way to get rid of a multiplier is divide. And whatever I do on this side, I do on that side. So now I'm left with r cubed is 3v over 4 pi. Now it's better, but it's not there. And I say, well, where do I go? What gets rid of? What is the twin or the pair of a cube? Addition has subtraction. Multiplication has division. Squares might have square roots. What would cubic roots have? Or cubes have? Cubic roots. So if I took the cubic root of this side here, I'd have to take the cubic root of this side. Now, that might look messy, but why did I take the cubic root? Well, the only reason I took it was because there was a cube there. And the only reason I did that was because it was going to cancel them all out. That's just like the other things got rid of it. And I end up then with, so let's just do that again. I've got r cubed, I had, was 3v over 4 pi. I'll write it here again. But this time I'm saying anything I do to the left-hand side, I must do to the right-hand side. So the cubic root gets rid of a cube. And they do cancel. So I get r is equal to the cubic root of 3v over 4 pi. Now it's a calculator. What have they told you in the exam? They've told you that the volume was 1,000 or 10,000 meter cubes. That was known. 3 is known. 4 is known. Pi is a number. The cubic root is on your calculator. You can work it out. So this is just pure calculation stuff. So for every equation in your log tables, and there are many, they're hiding so many, many more as well. So there we see it that the cubic root of r cubed is the cubic root of 3 over 4 pi times the v. That v is on the 3v, it's 3v over 4 pi. That's correct, yeah. So let's do a straightforward then. You might just rearrange the formula for the circumference of a circle. C is equal to 2 pi r, but I'm interested in r. So write that equation, flip it around, put r on the other side, and figure out what that equation turns to. So, C is equal to 2 pi r. I don't like this on the right-hand side. I'm going to turn it to the left-hand side. So the first step is 2 pi r is C. 2 is a multiplier. I'm going to divide by 2. Pi is a multiplier. I'm going to divide by pi. So r is equal to C over 2 pi. And the reason this is important to rearrange is that it's invariably the case that they'll tell you that the circumference of a circle is 10 kilometers. What's its radius? They're less likely to say the radius is 10, tell me what the circumference is, because that's just straight from the tables, whereas the other is rearranging. So here we have another one, rearranging the formula of a circle for the area of a circle. The area of a circle is A is pi r squared. Find r. You're interested in r. So give that a go. Sorry, not r, you're interested in r on its own. What is r in terms of the others? Okay, A is pi r squared. Don't like it on the right-hand side, I turn to the left. Pi r squared is A. Pi is a multiplication, it's just a number, 3 point something. I divide by pi, and I get r squared is equal to A over pi. But what's the sledgehammer that resolves the square for me? Its twin, square root. So if r squared is A over pi, the way to get rid of this square is to take the square root. And if I do it on one side, I must do it on the other. So therefore, r is equal to the square root of A over pi. And this is what's likely. What's likely in the exam is that they will ask you to use, they will expect you to know the formula or to be able to use them, but they won't give them to you in the standard presentation. They'll have twisted them around. So let's do this one now for the volume of a sphere. That's our pi r. V is 4 over 3 pi r cubed. And it says the question here is, the volume of a sphere is given, and you're told it's 30 pi. So V is 30 pi. So you look up your tables and you say V is equal to that is 30 pi. But what they want you to do is they say in the question, find the radius. And you know that that's r. So effectively, you're left with this equation. You know from your tables that you've looked up that this is the only table to do with spheres and, volumes of spheres. So that's the formula you have to use. You know that that's 30. So let's see how we go from here. Well, we can leave the v out for the moment because we know it's 30. So 4 over 3 pi r cubed is 30. We can get rid of the pi's actually because there's pi on both sides. Now you might decide to cross it because you're getting used to this. You've been doing it for years. The formal way is to divide by both sides. They're both gone. So 4 over 3 r cubed is 30. I'm not gone on the 3. So I'm going to multiply by the 3 here on both sides. And I end up with 4r cubed is 90. Now I just have 4 times something is 90. Don't like the 4, I'm going to divide by 4. Divide by 4 on both sides. And I end up with r cubed is 22.5. That's an awful lot nearer what I was looking for. But again, I'm interested in r, not r cubed. So I look up the toolbox and I say, what gets rid of a cubed? Oh yeah, it's the cubic root. And that solves it there. I just type in 22 in the calculator, hit the cubic root, some things like this, might be something like that in your calculator, or maybe just that. And I get the cubic root, and it's 2.8. Further questions, they're all pretty much the same. The area of a circle is 10, find its radius. So here you're told the area of a circle is 10. So I leave that to you. Now identify what formula you're going to use. What's the formula for the area of a circle? You know the area is 10, find the radius. Okay, the area of a circle is 10. So you look up the formula tables and you look for area and circle. And it gives you this equation that area is pi r squared or something like that. So that's the only formula in town really that you can use. And you're told that the area is 10. So now the question reduces to A, area, is pi r squared is 10. And again, you say, but my focus is on r. So I have to get r on the left-hand side and plug that in. So I can flip that around. If pi r squared is 10, well, I'm ready to go. It's on the left-hand side. Pi is a multiplier. You get rid of a multiplier by dividing. So r squared is 10 over pi, which we have here. And how do we get rid of a square? What's our unlocking key for a square? The square root. So the square root of r squared is really one cancelling the other out. So the square root of r squared, if the square root of r squared is 10 over pi, that's actually the same as r is equal to 10 over pi, because those two cancel. Now at 10 over pi, these are just pure numbers. 10 is a number in your calculator, pi is on your calculator as a function, one divided by the other, you hit the square root sign, you have your answer done. And this is as complicated now as it gets. The volume of a cone equals 10 pi. The cone has a radius of r, and find its vertical height. Now this is interesting because the cone is the only thing on your course with 3 variables. And if there are 3 variables, they can't ask you to find 2 of them, they can only ask you to find 1 of them. So that's the way the syllabus specifies it, because they only give you 1 equation. If they gave you 2 equations, you could solve it. But basically the formula, if you look up your tables for a cone, is v is equal to 1 over 3 pi r squared h. You've got a v in there, you've got an r in there, and you've got a h in there. V is the volume, r is the radius, and h is the height. They'll give you 2 of them. It is most unlikely that they'll say, the radius is this, the height is this, find the volume. It would be inconceivable that they'd give it to you that way around. They're much more likely to turn it around on its head. So in this question, they say, for the given cone, the volume is 10. So they're saying that v is known. So the v part is known. So it must be either the r or the h that we're going after. So I think the question said, the volume of a given cone equals 10 pi, that's v. If the cone has a radius r, that's r. Find h, oh, h is unknown. H is the thing I don't know. If h is the thing I don't know, h is my zone or my focus of attention. H is the bit I'm interested in. H is the variable I'd like on the left-hand side to actually just write down the answer then. Okay? So let's look at that. I've got v is the equation in the book, which is great. They give us that. In the standard form, which is that. And that's my table. Now, I might sort of take time out in a way and say, what do I know? So I just write a little table for myself and I say, but v I know is 10, that's fine. And I also know that, oh, they told me what r is. They did tell me that. So yeah, they told me that r was 2, so I have that as well. So, but I don't know h. H is the bit I don't know. Okay. So if I know that r is 2 now with this table, I can go back and plug it in here. Or if I know that h is a particular value or whatever. Okay? So I'll start here with the 1 over 3 pi r squared. I could decide to put in the value of r in there first, or do that, or whatever. Now, 1 over 3 pi r squared, if I start simplifying, is 10. I got rid of the pi because I divided here both sides by pi. So it's getting better. The third I'm not gone on, so I'm going to multiply by 3. I'm going to multiply this side by 3 and this side by 3. And now it's getting r squared h is equal to 30. It's not bad. And if I was interested in h, I could just divide by the r squared. Because how do I get rid of an r squared when it's a multiplier? Not in its own right, I divide by r squared. So I now have h is equal to 30 over r squared. But I was also told that r was 2. So if r is 2, that'd be h is equal to 30 over 2 squared. And that'll be 30 over 4. And 30 over 4 would give me 7.5, and that would say h is equal to 7.5. And then you'd say, but sure, that's what I was looking for. I found the variable on the left-hand side that I was looking for. It's done. And that's the full set of the first part of these questions. They're all done. They're all the formula that are there. No more difficult than that. They're all in the book. And all you're doing at any stage is taking one of the variables from one side over to the left and isolating it on its own so you can use the values given. Now we're going to look at practical, typical project maths questions on the second part of the paper, in addition to the first, where they're using those skills that you now have. The first bit was for the first part of the paper. So let's look at this composite shape. The composite shape here, drawn here, consists of a square of length 5 units. So the square, we'll assume that each of those is the same, is 5 units. And a semicircle stands on the top with its edges shown. What numbers of circles would have the same overall result? What number of circles of radius 1 would have the same overall area? Now, imagine that this was a slab of chocolate that was 1 centimetre thick or something like that. And it was all this sort of shape sitting on some machine. And you heated it all up again, and it all became liquid. And then you decided to pour it into these circles, like Maltesers, like. But they'd be flat, 1 centimetre high again, but they're now in circles. So I'm going to figure out how many circles of size 1 radius equates with that. Now, what happens here in these questions is that, let's assume for the moment that no chocolate is wasted and no chocolate is lost and all that. They have those types of questions as well. But for the moment, let's assume that there's no wastage. What you're trying to do is to find one composite shape here in terms of its total area and find out what total area of that equals this total area, and if those two total areas are the same, how many different units would I have to make up? So the first job we've got to do is to find out the area of that. Now, mostly it's to do with the formulae. Some of it is to do with your theorems and recognizing basic understandings of physical shapes. So what I want you to do is I want you to work out the area of that shape. Now here we have it again. We've got the semicircle on the top, and we've got the square on the bottom. 5, 5, 5, and 5, and this is 5. So give that a go, okay? What you might do is you might just take the square first, and then the semicircle. And write down the areas there. Okay, the square is 5 times 5, which is 25. That formula is given by the area, or the length by width. The semicircle if the semicircle has a, what's this distance here called in a semicircle? Is that the radius or is that the diameter? The diameter. And if that is the diameter then, R for that circle is 2.5. So the area is pi r squared, 2.5 squared. And that turns out to be 6.25 pi. But isn't that the area of a circle? Isn't it the formula for the area of a circle? Of circle would be pi r squared, isn't it? What would the area of a semicircle be? Half that, isn't it? So we divide this by 2, and this by 2. So the overall area of this sum then turns out to be that the square part is contributing 5 by 5, and the semicircle is contributing pi, r squared, which is 2.5 squared, divided by 2. Is that okay? And we can add those two up. Now we're going to turn a minute to the second part. And the second part is to get small circles of radius 1. So what I want you to do now is to work out what is the area of the small circles. Small circles r equals 1. What's the area of one of those? Well, what's our process? You go to the tables, you look up area. What's the area of a circle? You're told it's pi r squared. In this case, you're told it's pi. You're told the r is 1, which is great, and 1 squared will be just pi. So the area of each of these small circles is just pi. But the overall space we got for everything was 1 plus the other. So let's see now. Are we wasting any of this? Does it say if any of it is lost or any of it is wasted? Or what does the question say? Does the question quite precise and say how many would make up the same area? What number of circles would have the same overall area? It doesn't say if a bit was lost, if you weren't counting this bit, if this wasn't considered. It's what exactly would be the same. Is that okay? So if we look at area 1 is the composite, which was the square plus the semicircle, and that turned out to be 5 by 5 plus here pi r squared, which was 2.5 squared over 2, because it was a half circle. 25 plus, that's 6.25 or 3.125 times pi. Now, area 2, small circles. Each of those was pi. How many of those can go into those? How do you find how many of something go into something else? What's the method? Many 2s in 6? 3. How many 5s in 100? 20. How do you do it? Just divide. So we just say the answer is the number involved will be 25 plus 3.125 pi over pi. And that'll give you your answer to the nearest number. Pi is on your calculator, 3.125 is on your calculator, this pi is on your calculator, and you get your answer. Is that okay? I'm going to go off air now for a moment and have to cut this bit out. But anybody who is watching the notes on that will realize that I made a mistake. Isn't that right in the notes? And I chose the radius as 5 rather than as 2.5. Is that okay? So if you look at your notes on that and we go through and we'll cross that out, we can now edit it out. And thank you very much for not raising up the red card and saying you're talking nonsense. You're very good, because enough of you there, I just felt that you saw it, you spotted it, and said, these aren't what's in the notes, what's going on? Is that okay? But I made a mistake. So let's look at your notes. Let's look at the page it's on, I think. And if I'm not mistaken, it's on, where is it? Yeah, sure, I'll do it. I have the notes up here. So we just cut this bit out. And that's why I decided to continue with the class on handwriting stuff without doing it. What happened was, and I should have spotted it, and apologies for that, I went here with the units of 5. That was fine. Then this thing got a bit small. But here, for the given semicircle, I said that the semicircle was A is pi 5 squared over 2. That's incorrect. Why is not 5 squared? Because R was 2.5, not 5. So that should read 2.5 squared over 2. And then all of this is obviously going to go. So the thinking behind it is right. I just made a mathematical slip there, or a blunder, and yeah, I'd lose marks, a few percent for that. But what we'll do is, you just have to go online, print off the better notes, they'll be fixed up, and we'll sort that out, okay? But just, that's the only error in the thing, and I should have spotted that. And in fact, at one stage I did, and it's just one of those things that didn't get cleared off. But the logic is exactly the same. So thank you for not stopping me in midstream. Now, I think the next question is comparing volumes. Is that right? Is that the next question on your? Yeah, okay. And this, like the rest, is correct. So I think I'll go back on. I think I'll go back on air. Now we look at the question on comparing volumes. Here we've got a cylinder, and a cylinder of radius 5 centimeters contains water up to a height of 8 centimeters. 2 identical cones of base radius 2 and slope length 4 lie at the bottom of the cylinder. If the cones were removed, what drop in water level would occur in the cylinder? This is all examinable material and all available from the formulae tables and from a manipulation of the formulae tables. So here we've got our cylinder drawn like this, and the water at the moment is up to the 8 centimeter level. Because at the bottom of it, there are these 2 cones here. We're also told the radius of everything as well in the cylinder. The radius is 5 centimeters. And we're saying if we went in there and scooped those 2 things out, how much would the water fall by? Because it's going to fall a bit. Now, what's going to happen? Assuming that, we're not assuming they come out dry, but we're not worried about the tiny bit of water that's stuck to the cone. We're talking about, look, let's be reasonable here. Is that okay? So what we're saying is that when these 2 things come out, the volume that was here in the 2 cones is going to be exactly the same as the gap and the change in the volume here. So these are typical questions. We're going to have V1 is V2. Just as we had before, area 1 is area 2, we now have to match the volume of these 2 things, total, to the volume of this cylinder of water, the band of water that's falling. And those 2 things have to be equal. That's all we're doing. Now we have formulae for this, we're going to take our time, etc. But that's really what we're going in to look at. So now we start looking and say, well, what numbers did they give us? We read the question again and we say the cylinder is radius 5. Okay, that's important. So that's this fella here, and that's the cylinder. Okay, so that might be R for the cylinder. Okay. The height is 8 at the moment. We might call that H there for the cylinder at the moment, or HC1 for now. The cones are radius 2. Well, they're over here. So they're sort of radius. We better call that CY because we also have CO for cones. So that's the radius of the cone. And the slope length is 4. And slope length 4, that's a bit interesting. They're saying that the slope length, not the vertical height length, but the slope length is 4. Oh, I have to look that one up. So this one here is sort of L in a way. Again, it's the L for the cone, CO, and that's L. Now, can we do this question? That's about it, really. We've no more data. Now, we start looking up the tables, and we have a small problem. When we look up the tables, we find that there's a formula for the height and the volume of a cone, but it's given a bit differently. It basically assumes that the cone, like this in 2 dimensions rather than in 3, like obviously it's got a sort of a base around it, but let's do it. That looks like a boat, so I won't do that. Very poor. But let's imagine just sticking with 2D for the moment. We are told that we are giving the side, or the length, the slope length, but the formula book gives us the vertical height. Now we do know the radius is 2, but how do we get this thing here? And this now is where these questions require us to know the relationships on the other part of the course with the theorems, and in this case it's Pythagoras. Because it's a right-angled cone, it's a right-angled triangle. And because it's a right-angled triangle, if this is 2, that's 2. Because it's the center, it's the same radius. And if that's 2 and that's 4, and this is h, from Pythagoras we know that 2 squared plus h squared is 4 squared. So that's really the equation. And we should now be able to find h. We are interested in h. It's not unusual for us to see h on the left-hand side, messed up a bit with a few other sort of hangers on. So how do we solve that? Well, 2 squared plus h squared is 4 squared, just as we had here. We'd like to get rid of the extraneous stuff, so h squared is 4 squared minus 2 squared. Using the PEMDAS or the PEMDAS, let's do these powers and get rid of them. H squared is 16, 4 squared, minus 2 squared is 4. 16 minus 4 is 12. H squared is 12. But our focus of attention is on h. And to get h, we'll just have to take the square root. So we get h then is 3.464, etc. We can decide we want that to so many significant digits or not really. But we should keep it reasonably long in our calculator, particularly if we're using the number again. Because if you shorten that at this stage and you use it again, your answer is getting progressively incorrect. So the volume of the cone can now be calculated using the formula. Oh yeah, we go back to the table. What did the table give us? It gave us a formula for volume of a cone that said V is equal to 1 over 3 pi r squared h. And in fairness, we were using L. And we've converted it now to h. And h is our vertical height. So there's nothing we don't have. We have the vertical height, which we just got, of 3.46. We've got the r, which we were given, of 2. We can plug in the numbers in a calculator and we can get an answer. That's just numbers. Now, we have to remember in the question there were 2 of them, so instead of 4 over 3, it's 8 over 3. And we stick in that number and we get a number. And that basically is V1, if we called V1 the 2 cones. Now we're going to go into the cylinder and see what have we got in the cylinder. Okay. Well, in the cylinder, we have this shape here, and we've got a lot of water. And we're interested in this space here. But it's volume, so if it's volume, we look up the formula for volume of a cylinder. And if we read that, it tells us that the volume of a cylinder is V is pi r squared h. Now remember, this is h is generic h, it's not the same h as the cone. This is just our h in the question. And what are we interested in? We're interested in the h at this stage that is really height 1 minus height 2. The gap here. How big is this gap? This band of water that drops. How big is that? And we don't know. We're going to say it's h. But we do know that when it's spread out, it's spread out precisely in this cylinder. So if the height is h, then we do know that the volume is pi r squared h, because that's the formula for a cylinder. And because we know that the cylinder has a radius of 5, and r is 5, we then know that v is equal to pi 5 squared h, or that v is equal to 25 pi h. That's V2. That's the volume of water. Now, it makes sense that the water must be exactly the same in volume as the stuff that came out. Nothing appeared out of nowhere, and nothing got lost in the process. So V1 is V2. So if we go back to what we got for the other, we can then say that 25 pi h for V2 must be the same as the formula we got for V1. So if we look at that, this is what we got for V1. Excuse me. The 8 over 3, and this was our V2. And now all we have to do is just solve the equation. There's a few things that are common. The first one is pi, so they're great, they both go, or you can divide by pi on both sides. The 8 over 3 is not great, but you can sort of leave it there. The 25 is there. So basically, you can divide that by 25. H is equal to 8 over 3 times 25 times the square root of 12. Now, H is equal to this. So that's how much the cone would fall. So how was the process again? All we did was basically volume 1, volume 2, make them equal, write down the formula, equate them all out, and that's it. So before you started on that question, you had to say, what's happening? Get your sense in the project maths space to say, you know, the drop in the water has to be the size of the two cones. It can't be less and it can't be more. Nothing else happened. The very last question in this topic is very similar. It just adds a slight twist at the end. And this is the one about making candles. And they say a company wishes to make candles from a cube. The cube is 550 centimeters in length. The candles comprise two parts. And the candle consists of both the sort of a stub part like a crayon pencil and then the writing bit at the top, the tip. So it's a cylinder for a bit and then a pointy cone at the top. Now what we're going to do with this is we're then going to make these candles from a cube of wax. So what we have here is a cube of wax. So imagine here, I'll try to do a cube. Imagine you just got a big lump of wax. You bring this into the factory and you slowly melt it down. And it's all become a gooey liquid or something like that. And you wash it through then the equipment, and there's holes then where the wax just falls into these things that are filled up, like the wax crayon, the Crayola wax crayon that you're all familiar with. And it turns out that the holes fall into a pattern just like this. And that's what you end up with. How many of these will you get out of the cube? Now, in this question, it's volume and volume. But because of the process, some of it gets a little bit sort of gooey and sticky. Some of it doesn't go fully into the gaps, etc. And they say they're going to lose 3% of the wax. That's really what's going to happen. There's going to be a bit of wastage. So here we've got volume 1 in a way from here. We're going to have volume 2 from all of these crayon things. But millions of these. There's thousands of these or whatever, lots of them, more than one. And there's also waste. There's also this sort of 3%. So we'll have to figure out that. So if we take the volume and we took 3% of it away, then we'd be making pure candles with the rest. Or we'd say volume multiplied by 97%, or whatever you want. But we've got to get rid of some of this is going to be wasted. Now, that's the actual problem solved in your head. Conceptually, you figured out exactly what's going on. Now we just operationally have to go through that in terms of the formula, plug in the stuff and do it. Okay, so how do we do it? Well, we're going to start first maybe with these candles. How big is the candle? Well, the candle is made up of a cylinder section, as we saw there, and a top part. And here's the cylinder section and the top part. So, like anything else, I think it's important to talk about them in two parts. Cylinder first, and here's the cylinder. It's volume. If it's volume, you go to the log tables. You go to the tables and you say, where's the formula for the volume of a cylinder? And it is here as V is equal to pi r squared h. But in this question, it's not that bad, because you're actually told the height of each. The height is 20 centimeters. So in this particular question, you're actually told that the height h is 20 centimeters. And on the or, you're told that the radius is 2. So what's the deal here? This is pretty handy. It's just really plugging those numbers into V. You don't even have to twist this around anymore. V is pi 2 squared, so V is pi 2 squared times 20. And we see it here, pi 2 squared 20, V is 80 pi. Now that's the butt of the crayon, or the candle. Now we've got to get the bit on the top. So the bit on the top now is, we have to get the conic section. And the formula for the conic section is V is equal to 1 over 3 pi r squared h. Now again, we're looking at this and we're saying, but what are they telling us? Do we have all this? Do we have to go around the houses to find this stuff? What's going on? And they say, okay, no, when we were told a cone of vertical height 2. Oh, great. So here we're told that on the conic section, the vertical height, not slope height, h is 2. The radius is 2. So V is equal to 1 over 3 pi 2 squared 2. Everything we have again. So we get the volume of this. So that's given. So V is 8, well, and then if we add the two together then, we get 80 for the first bit plus the other bits. Because if we multiply this out, this is a third. 2 by 2 is 4, by 2 is 8, so it's pi 8. So it's really 8 pi over 3, and that's the conic section, and that's the cylinder section. So now we have the volume of this, V1, let's say. But where are these candles coming from? Well, they're coming from one big block of wax. This is our V2, or sorry, that was V2, this is V1. The block of wax, the cube of wax, if we look at that cube volume, what's the volume of a cube? It's length by width by height. 1, 2, 3. So if it's a cube, then all those lengths are the same. And I think we were told it was 50, was it? I think that we were told exactly what it was. I think it's 50. So if it is, we can then say 50 by 50 by 50. So the whole volume now we have is 12500. Well, what are we going to do with that? We have the cube. We were told that was 50. We now know it's 125. But was there wastage? Yeah? So we can say 125 was 100%. What's 97%? Couldn't we do that? Or we could say 125 is 100%. What's 3%? And 3% of 1250 is 3750. We have to take that from that. Or if we multiplied it up, we'd get whatever that number is. Is 121, is it? 250. So either way, we could do the crisscrossing and get it. So effectively what we have is 125, 250 wax to make candles. And they're all 82.66 each. How many candles can we make? Well, if you have €100 and it's €10 for a pizza, you can get 10 of them, one divided by the other. If you have 121, 500, and it's this each, it's one divided by the other. So you end up getting this divided by this. That's just pure calculator. That divided by this, multiplied by pi on the bottom. So we end up with 467.842. How many candles can we make? Can we make this 0.8 of a candle here? No, because it's not good enough. It would look odd in the set. It wouldn't be right. So basically, even though you would think you would round, in this particular business case, you wouldn't, because a candle isn't a candle until it's a full candle, full the right size. So it's 467. So it's an example of truncation. I think that was pretty okay on time, was it? We're now done. See you at 2.